OK, here comes the DNS Lookup walkthrough. So this is kind of cool. You can actually do this at home. If you open up a terminal, there's a utility called dig that runs DNS queries. So we're going to run a DNS query together and see all of the things we talked about in action. And here we're adding no recurse because I want to do the recursion myself. I don't want to outsource to a recursive resolver that takes all the fun away and just gives me the final answer. I want to see it in action. That's why I put this flag here. So this is kind of cool. You can try it at home. It makes you feel very smart when you see all the code and you can actually understand what it means. So here's the terminal command. It says, I want to know the IP address of eeks.berkeley.edu. That's my query. I want to know its corresponding IP address. So when I start, I don't know where the name servers are. I don't know who to ask. When I don't know who to ask, I'm going to go to the top. The person who definitely knows my answer or can help me is the root. And as mentioned earlier, the root IP addresses are usually hard-coded. Everybody knows them. If you don't know, just ask somebody. It's a well-known piece of public information, like the name of the planet we live on. So that's the publicly known root IP address that all computers know. And here's the answer we get back. It looks really fancy, but if we break it down, it's all the implementation details we've been talking about, and it's really just those two English sentences that we talked about at the very beginning, encoded using actual code and bits. So this is the actual DNS response. Let's start with the header. It even says header for us. There are a bunch of flags. Don't care about those. There is an ID field. Remember, we said that it associates requests with responses. So when we sent out this query, our computer must have chosen 26,114. And when the name server got that query and sent back an answer, the answer had the exact same ID. That's how we matched our question with our answer. Here are some flags not talked about. And here are the record counts. So it tells us there are 4 sections. There's 1 record in the query section or question section, 0 records in the answer section, 13 in the authority section, 27 in the additional section. This tells us exactly where the records are and how many are in each section. So let's go through each section one by one. Each section just has a pile of records. All DNS data comes in records. So ultimately, this is just a pile of records sorted into 4 sections. The first section is question. So this tells us what the question is. Usually when you send a DNS query with a question, the name server will reply to you with the same question, just as a reminder of what you asked. So this is the reply that's saying, you asked for the IP address of eeks.berkeley.edu. How do you encode that English sentence into code? We will use an A-type record. That's a data type. On the left-hand side of the data type, you put a domain name. It's what we asked for. On the right-hand side, you're supposed to put an IP address, but the name server put blank, and we put blank because it's a question. We don't know the answer. So that's why we put blank on the right side. And A is just the data type that tells us the data type on the left and the data type on the right. That's the question section. Now we move on to the answer section. It's blank. There's 0 records. We can see from the header. There's nothing in the answer section. That tells us that the root name server did not know the answer to our question. So when we said in English, I don't know, the way that it actually says I don't know is by leaving the answer section blank. It contains no records. Now, when you don't know, you have to redirect to someone else who can help. And these 2 sections, authority and additional, are how we redirect to someone else who can help. Now, the reason why there's 2 sections and 2 records to encode the identity of who can help next is a little bit unintuitive. I'll give you several explanations, and you pick your favorite. So one way to think about it is that there are 3 pieces of information you need. You need to know, what is the next name server an expert at? They are a .edu expert. You can ask them any .edu questions. You cannot ask them for www.google.com or something like that. So the first thing we need is what zone they're responsible for. What are they an expert in? The second thing we need is their human readable domain name. so we know who they are. It's like asking for their name. And the third thing we need is their IP address to know where they're located. That's like asking for their address. So we need 3 things in total. What are you an expert in? What is your name? And where do you live? We need 3 pieces of information. A record only holds 2 pieces of information, name and value. So if I want to encode 3 pieces of information, I need 2 records. That's just an unfortunate reality. So the first record has what they're an expert in and their name. And the second record has their name and their address. So if you want to, you could think of it that way. I have 3 pieces of information. They don't fit into a record because a record only fits 2 values. So I need 2 records. That's one way to think about it, if you like. If you didn't like that explanation, let me give you another one. Let's say we stopped right here with the authority section, and we said there is somebody else who is an expert at .edu, and their IP address, or their name, is a.eduservers.net. Let's say we just sent this, and we stopped right there. What would the resolver's next step be? So if we're the name server and we send this answer back, what's your next step? Well, I see this. I know I need to talk to the .edu name server next, and this is their name. But if I want to talk to them, I need to know their IP address so that I can send them questions. So if we only gave this record to the user's immediate next step would be to do another DNS lookup to figure out the IP address of a.eduservers.net, the next name server I should contact. So now the client is doing a DNS lookup inside of another DNS lookup. They were trying to find eeks.berkeley.edu. They got redirected to this person, and they're doing a second DNS lookup to find them. So now we're doing DNS lookups nested in DNS lookups. And what if that one triggers another DNS lookup, and that triggers another DNS? That's too complicated. We don't want to do that. So the name server says, I know you're about to ask for this IP address because you're going to talk to them next. So instead of sending you on this wild chase where you're doing DNS lookups inside of lookups inside of lookups, let me just stop all of those circular problems and all of that chaos by just giving you what you're asking for. I know you're going to ask for this IP address next. So in the additional section, let me just give you the answer. That solves all of our circular problems. So a second way of thinking of this 2-record approach is that the first record has what we need. It tells us who to contact next. And normally that would trigger a second DNS query, which is chaos and is a circular problem. So the root name server just preempts all of that by also serving the answer to the follow-up DNS query. Both of those are valid interpretations. You pick your favorite. So anyway, these 2 sections combined tell us who to contact next. It's a .edu name server. That's what they're good at answering. Here is their name. Here is where they live. Now, in case you're wondering why there's multiple, it's because of redundancy. So instead of having just one name server that's a .edu expert, there's actually 13 of them. And that's good because if one of them goes down, there's still 12 you can talk to. There's also 13 root name servers, so not just this one, but also 12 others. And a lot of name servers out there are duplicated like this for redundancy. That's why there are 13 records here, because there are 13 .edu experts. And down here, we give you the IP addresses of all 13. You pick your favorite. So for redundancy, there's lots of them. I could really pick any of them. I'm going to be lazy and pick the first one. That's their name. This is their IP address. Let's go talk to them next and see if they can help us with our query. So now for the second step of our DNS lookup, we asked the root. They didn't know the answer, but they redirected us to someone else who can help, namely the .edu name servers. We got 13 of them. We picked our favorite, which was the first one. And here's their IP address. Let's go talk to them. So that's who we're going to talk to, the .edu name server. This is an IP address that we got from the previous response. And we're asking the same question. Our question doesn't change. Here's the response we get back. I won't go through it again to avoid boring you, but it's basically all the same things. Once again, there's a copy of our question. Once again, there is no answer. So the .edu name server doesn't know the answer either. And once again, there are a few authority and additional records to help us get redirected to the next name server that can help. These records combined are saying, I don't know the answer. The next name server you should contact is a Berkeley.edu name server. They are an expert at Berkeley.edu related queries. So go talk to them. Here is their name. That's their human readable domain name. And in the additional section, because I know you're about to ask me this next, here is their IP address so you can actually contact them. And for redundancy, Berkeley operates 3 of these servers. So now we know Berkeley.edu's name server and its IP address. Let's go ask them the same question. And finally, we get an answer. We know there's an answer because the answer section is finally not blank. Thank God. And so here we are. It's not blank. Here is the human readable domain name. Here is the IP address. The type is A because that's the data type you use when there's a domain name on the left and an IP address on the right. And in case you're wondering what these numbers were, that's the time to live. It tells us that you can keep this record around for 24 hours. So if you ever ask for eeks.berkeley.edu's IP address again in the next 24 hours, it's in your cache. You don't have to go through all this trouble again. So that's the whole story. That's a DNS lookup walkthrough in all of its glory.